Hello, this is Mr. Huff, and I really quickly want to go over density with you. You need to keep in mind that density is a measure of the amount of matter per unit volume. And if you consider the two diagrams here, you can see that something with high density has a lot more matter in it. Consider each green dot as a molecule. Than something with low density, which has more space between the molecules. If the density is less than 1, which is 1 gram of water per cubic centimeter, it will float in water. And if it's more than 1 gram per cubic centimeter, then it will sink. As far as mass and weight are concerned, really you just need to understand that there is a distinction. Mass tells us about the amount of matter. Weight is related to the force of gravity. The example I like to use is if I look at your total mass, that's your body, and if I put you on the moon, you have the same amount of mass. So if you if your mass is 60 kilograms on Earth, it will also be 60 kilograms on the moon. However, if you go to the moon, you have less gravity. If you weigh 120 pounds on Earth, you would only weigh 20 pounds on the moon. And there's some formulas we're not going to use so much, but we'll talk about some physics a little bit later. And don't confuse mass and weights. Let's look at this slide together. Main thing you need to understand is the distinction between the two. One is telling us the amount of matter, the other one is related to a force of gravity. System International, mass is measured in kilograms, and weight is measured in newtons. When you look at U.S. customary, normally we talk about pounds, and there is an obscure unit called the Slug, and it is used to represent weight in U.S. customary, and you probably will never see it, so we're not going to worry about it. On this page, you will see that there are some conversion factors. The ones that you need to really pay attention to are the kilogram equals 2.2 pounds, and 1 pound is 0.4535 kilograms. You don't need all of those decimal places. Something else you might want to pay attention to is down here. 1 pound is 16 ounces. 1 ton is 2,000 pounds. Again, I'm not going to worry about slugs. And this is relating pounds to newtons. What I have planned so far, we will not need to do that, but if I decide to use this, we will discuss it more. Okay, we're getting down to the formulas. Here are the formulas, and they are essentially the same thing if you drop the subscripted M and the subscripted W. Mass is volume times density. Density is mass divided by volume. In the same way, weight is volume times density. Density is weight divided by volume. Be sure you have these in your notebooks and what they mean. It's a good idea to keep units with it. We need to talk about that next. When we talk about System International, there are two units, and I'm going to throw a third one in. It's grams per cubic centimeter or kilograms per cubic meter. Keep in mind a gram or a cubic centimeter and a cubic meter are very, very different. A cubic centimeter is 1 centimeter in every direction, a little cube like that. A cubic meter is 100 centimeters height times length times depth, and it's a very large area, okay, or volume, okay. When you look at U.S. customary, pounds per square inch or pounds per cubic, not square inch, cubic inch, or pounds per cubic foot. Those are the ones we'll be using. Another one I needed to point out for System International is grams per milliliter. A milliliter is equal to a cubic centimeter when we use water. Because most of our most precise measurement tools are in inches, we will be requiring U.S. customary pounds per cubic inch for our assignment this week. Usually, if you have reference tables, it will display both the System International and the U.S. customary density values. And here's an example of that. Okay, two ways of measuring these. A balance will measure mass accurately, even on the moon. We are going to use these because that's what we have access to. You can also use spring scales. These depend on the force of gravity. So a spring scale will only work on Earth. It will not work in outer space. And on the moon, it would measure 1/6 of what it measures here. And we're going to use two different ways to find the volume of an object. Volume can be determined with geometric means, where you take a bunch of measurements, do a little bit of math, and find the cubic centimeters or the cubic inches. Another way to do this is to submerge an object in water, and the amount the water is displaced tells you the volume of the object. Also, we can, with the formula sheet I've given you for Project Lead the Way, you can use geometry to find surface areas and volumes of features like rectangular prisms and spheres. If you're looking at a sphere, here's the formula for volume and surface area, and a rectangular prism. Take a look at your formula chart that I issued earlier, and that will help you. So you should have that taped down securely in the back of your notebook. And this is also describing how to measure with water displacement. It's a good idea to use more than one object and do an average. Actually, this wouldn't work because these are different things. So that's just showing you how to look at the water displacement. Next thing we need to talk about is if you're using glass graduated cylinders, you will see a meniscus, and when you take those measurements, be sure and follow the bottom of the meniscus. The meniscus occurs because of the surface tension of water and its attraction to glass. The materials we use in my room are nylon, and it doesn't make a meniscus. And then here's a practice problem. One other way I want to describe for finding the displacement by in water, we will use a triple beam balance, and we will suspend your object in water in a beaker. If you know the mass of the water and the beaker together, when you suspend the object in the water without letting it touch the bottom, the only weight that is added, the only mass that is added, is the amount of water displaced. And you can get a really, really accurate measurement of volume using grams and a triple beam balance where you suspend an object in the water. We'll be doing some of that this week as well. And that is all I have.